Welcome to the Data Physics channel. This is Shekhar, and in this tutorial, we are going to see the exploratory data analysis using Python libraries, that is Pandas, and we will carry out this data analysis on the very popular car dataset. So let's get started. So basically, when we say it's a data analysis, using Python. So mostly we have to do the data exploration um, using Python libraries like Pandas, NumPy, Matplotlib, Seaborn, where we can clean the data. We can read the data, read the CSV files, Excel sheets, text files. We can uh, clean the data. We can manipulate the data. We can pre-process the data, and we can also visualize the data. And on top of that, we can answer some of the business questions by using data filtration, uh, data manipulation by using this Python libraries. So here the Pandas is the very popular, fast, flexible, and easy to use the open source data analysis and manipulation tool. This is actually an open source library. So mostly there are two data structures of the pandas. One is series and second one is the data frame. So data frame is nothing but the table itself. Okay. So let's get started with the car data set. So here in the exploratory data analysis, these are the steps we are going to follow. The first we will import the packages, then read the CSV file, then we will do the sum of the basic data analysis, then we will clean the data, we will pre-process the data, we will manipulate the data, and later on we ask some of the business questions and solve these business questions. Okay. The first step in the exploratory data analysis is what we have to do. So we have to import the libraries like Pandas, then NumPy, Matplotlib, and Seaborn. So this is the first one. Second, we have to read the data, the pd dot read underscore csv, and you have to write the file name, or you can provide the file path, and you can read it here. So I'm reading the first two rows, and you can see here these are the columns, and I can see only two rows. Okay, let's see how many columns and the rows are there. So 11,914 rows are present and 16 columns. So dot shape will give you the number of rows and columns. So what is the uh, type of this particular variable? It's a pandas data frame. Yes, you can visualize the last 5 rows of this data set by using a dot tail function. Okay. Now already we know that this is number of rows and columns. Now I want to display the list of columns in the data. So you can use the this is the variable I created for the car data, and here is the columns. You can see here these are the list of columns. Then we will see what are the data type of that particular columns. So whenever we say it's a data type, so mostly when object is comes under this strings are nothing but the categorical column, we can say. This model is also object, then here is the integer, these are the floats. Okay, so it will give the data type of the this particular columns. Okay. So car, the data frame dot info, that will give you, this method will give you the all the information about the data set, along with the columns, data type, the null values. Okay, so you can see here the range is this and indexes are from this to this, total number of columns, and these are the non-null counts in each column, and it's a data type. So this dot info information gives you the total information about the data. Now we are going to check very important things in the data set, whether there is any null values are there or not. So dot is null dot sum. So directly it will give the count of null values in the data set. Okay, in each column. So here you can see here is the null values, three null values. Here is the 30 null values, and the most of the null values are in the market category. Okay. Now here by using a pandas you can select the specific number of specific columns, and you can create your separate data frame. Suppose I want to create a data frame of these three numbers, these three columns, then you can create a list of columns and you can pass it here, so that you can create a separate data frame. Now this is only a data frame containing three columns: make, model, and year. So next one is we will some alter the data. So we will change the column names, because here you can see these column names are here. It's a big, so there is a gap between the two words. Okay, so we will make it standard by removing the gaps and make it standard columns. Okay, so this is the column name, and here what I'm doing, so dot rename and providing the column, and I'm providing the dictionary with original column name and changed column name. This is the new column name. The same I am doing for each and every column and changing the column. Okay, now you can see here, yes, now these columns are changed. Okay, now these first three columns I have not changed, only I have changed only required columns, and these columns I have provided the key, and the value is the new columns. Okay, now the car data 2 is now ready with renamed columns. Okay, now there are missing values. How to treat these missing values? So there are two ways: you can drop these missing values, or you can input the missing values. So in this case we are going to input the missing values in missing columns. Okay, so initially we will see how to drop this. Okay, so there are two approaches. So I have created separate data frame, so original data frame will remain as it is. So if you use this drop na and how equal to any, if you provide this argument, then you can check the all these null values are removed from the data frame. Okay, you can see here now car data 3 is without null values, but you can see here the that number is reduced. So initially we are having the 11,000, around 11,000 records. Now it's 8,084 only, because we have removed this null records. So whenever we are removing this, means we are removing the entire row. But one more approach is there. So suppose the whole the null value in the all the columns are present, then it will remove this option. So how is equal to all, here how is equal to any, here how is equal to all. But when you import this, when you execute this, there will be you can see there is a no removal of the null values, because there is a no case where the all the column having the null values. So this is as it is. But what we are going to see, we are going to input the missing values by using a meaningful value. So we are going to input this categorical values with the mode, and numerical value with the mean and median. Okay, so here you can see for fuel type it is the regular unleaded is the most frequently occurring value. So we will input this uh, fuel type with regular unleaded. Then here is the two approaches engine HP. You can go with the mean or median, and for cylinders number of cylinders means we will fill it with the 4 because that number of cylinders should be an integer value. So you can fill it with the this median number or mode number, not with the this mean value. Okay, then the categories, it's a crossover is the category which is most frequently occurring. Now we will start with this missing value imputation. So first we will fill the data for this category. So category we will fill it with the crossover. So this is the syntax. When you run this, these categories, you can see these categories is dot fill na with crossover. So crossover is this we filled with a mode value of the category. Mode value means it's a frequently occurring value. Then cylinders we are filling with 4 value 4 because 4 is the mode of this uh, 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 particular column. This engine HP we are filling it with the mean value of that column. So here it is. The number of doors we are filling it with the again the mode value, and the fuel type is also we are filling with this. Now you can see here. Now we have filled all the missing values, inputted missing all the missing values. Now there is a no missing value. Now you can see the shape of this. The shape is as it is because we have not removed the missing values, but we have imputed the missing values. Now the next important thing is whether we have to check whether there is any duplicate values are present in the duplicate records present in the data set. Yes, so car dataset 2 and car dataset 2 dot duplicated. When you do that, you can see there is a duplicate records you can display, but you don't want this duplicate records, so you have to remove this. So that I'll be creating a new data frame, that is car data is equal to car data 2 dot top duplicates, and we'll check. Now I have removed this 7 almost 715 rows because these are the duplicated, and now I am having only the unique records. Now these are the unique records, and this is the final data frame. Now we have checked this, we have cleaned the data and done some data manipulation also. Okay, now we'll check the numbers. Okay, so I want to check name of the car manufacturers in the data frame. How many numbers of the car manufacturers? Now car dot make is the column, dot unique. When you do the unique, then I'll say it's these are the list of manufacturers, car manufacturers. Now next one is how many of this, means you, this is the list, means you can take a length or you can do the n unique. So you will get the number of unique car makers are 48. Okay. Um, yes, this will check later on. So what I want to check, I want to check the number of cars in each make. Each make means how many cars per manufacturer is present in the data set. So I'll do the value count dot value counts, and when you run this, So you can see these are the make, and these are the value counts. So for Chevrolet we are having 1083, Ford it's 825 cars. Okay, so next one is we'll check for the style. You can see for the style we are having sedan, four-door SUV, coupe with numbers. Likewise, you can do this for all the categorical columns. There are so many categorical columns already we have seen, um, and these categorical columns you can apply this value counts to each categories. Okay, so we'll get this value counts. Okay. Now, if you check the basic statistics of the numerical column, then you have to use the describe, dot describe. So dot describe will give you the statistics of numerical columns. Now numerical columns is year, engine HP, cylinder, number of doors, highway MPG, city MPG, popularity, and MSRP. So you can see here these are the nothing but the specifications of the car. Okay, so you can see this. This is the statistics. Now, if I want to check uh, some of the data, suppose car data, where what I can see here, the minimum engine cylinders are 0. But whenever we say it's a engine cylinder is 0, means it should be a electric car. Okay. So when I put this condition here, engine cylinder equal to 0, then you can see there are so many cars are there with engine cylinder is 0. Engine cylinder is 0 means fuel type is electric, means these are the electric cars are available. And now we are having how many cars total? Okay, this data you can put here shape. We are having a 56 cars, the electric cars which are present in the data set. Okay, so this is all about electric cars. Then if you want to check the Fiat car, which is electric one, so if I want to display the data for the Fiat Fiat electric car, so first I will filter the data. So car data set fuel type equal to electric, so it will give the electric data, means this is the data of electric. You can use the fuel type is equal to electric, or you can also use another approach is the cylinder number of cylinders is equal to 0. Okay, and then you can apply one more condition, make equal to Fiat, so it will display the Fiat electric car data. So now there are 3 cars are available in the Fiat with this. Okay, now I think yes, this is not this is almost the same data is here. Okay, so only change is what here the number of years. So this is not a duplicate data, but the year of manufacturing is 2015, 16 and 17. Okay, so next one is I want to use approach, one more approach here. So you can see you can put these two conditions simultaneously and you will get the data, the same approach. Okay, now I want to check what is the maximum car price in the data set. So whenever I say it's a maximum car price, okay, let me remove this and put it here. And what is the maximum car price in the data set? So MSRP is the maximum selling retail price. Okay. So dot max, when I do this, so I'll get this is the maximum value. And if I equate this maximum value in the data set, so I'll get the car with the maximum price. So Bugatti is the most expensive car in the data set. You can see the most, I'll say, the expensive car in the data set is Bugatti. These are the specifications of this car. Okay. Yes. Now I want to see what is the Tesla car and its maximum price. Okay. So for that, first I will create this Tesla data. Then I'll apply this Tesla data with MSRP dot maximum, and I'll put that Tesla data the condition that is equal to maximum. So I'll get the maximum, the most expensive car in the Tesla category or Tesla make. So you can see here this is the maximum price and this is the for Tesla. So basically I want to check uh, most most expensive Tesla car. Okay, most expensive Tesla car is this. Okay. Uh, yes. Now the next part is data visualization. So we can visualize some of the data by using this. So here is the car data make dot value counts, and I want to plot the bar plot or bar chart dot plot kind is equal to bar. So when I run this, you will see there is a the make wise you will get the bar part. Okay, here the same you can apply it for the style. So number of the cars which are present in this particular style. So it's nothing but a count plot in the C-bar actually. Then same for the size itself also you can run. You can see three: compact, mid-size and large, and their count. If you check the distribution of the price, we can check the histogram. Yes, you can see this is the histogram with which you can see the distribution here itself. Engine HP will check. Yes, so most of the power HP power available in the 200 to 300 almost. Again here the make, no, this is already we seen. Yes, next chart is the box plot. So when we check the box plot is basically used to check the outliers. You can see there are so many outliers there. For engine HP, when you apply this box plot, you can see very nice box plot here. So where you will get the minimum, maximum, then mean value, 25th percentile, 75th percentile. Okay, and outliers. These are the outliers. Okay. MSRP that already we have seen. Yes, popularity, when we plot the KDE plot, so KDE plot is nothing but the histogram, but it's a smooth curve actually. So for popularity, when you plot kind is equal to KDE, then this is already we plotted. Now we'll check the relationship between the numerical columns. Now numerical columns are HP, engine HP, highway MNG, city MPG, popularity and MSRP. Okay. So for that I'll use the dot core here and use the cbon dot heat map dot core, and annotate is equal to true means it will show the percentage of correlation. Now nobody is yes, so you here you can see The city MPG and city highway MPG are most correlated variables. There is a slight correlation in between price and the engine HP, but highway, these are the same values actually. Here is the engine HP and the MSRP, yes, the same value. So these two variables are having the correlation. We'll check the scatter plot between this engine HP and MSRP, and we will give the title this. So, so this is the nice scatter plot of uh, the engine HP and MSRP. Okay. Now next type of the chart we are going to see is the pie chart. So pie chart is we will check for the size, and we'll check the percentage of each size of the car. So compact is 39%, count is 36, and large is 24%. Car make, when you check, it's a number of manufacturers of 48 actually. So it's a messy the pie chart you can see, because these numbers are very small. So maximum percentage is Chevrolet, Ford, Toyota. You can see this is the contribution of each manufacturer in the data set. In case of the style also you can do. The sedan style is most popular one. Four-door SUV is there. Okay. So next one is the we'll ask some of the questions, the business questions, on the last part of this exploratory data analysis. So already we have checked this. So display the data for the Chevrolet cars. Now I'll make car data is equal to make is equal to Chevrolet. Then you can display this all the data for the Chevrolet cars. Now next one is I want to display the data of cars which are manufacturing 2008. So I have to give only this condition. The year is equal to 2008. You can see all the car data with 2008 manufacturing year. I want to see the data of engine power more than 330 HP. So I just have to give this comparison. So more than 330 or 330 HP. Okay. So these are the cars available which are more than 330 HP. So I want to check the car which is price is more than 25,000 and less than 28,000. So I want to filter out these cars. Now 965 cars are available in that range. You can see here. This is the range between 25,000 and 28,000. Now I want to check the specifications of the car, which is BMW, and the series is 1 series M. So first I will filter the data, which is BMW data, by using this condition, and then I'll apply the condition for this BMW data with model. So I'll get the specification of BMW car with 1 series M. You can see here. So most expensive car in the Tesla, we have already seen this type of question. So this is the maximum price of the Tesla car, in the Tesla car, and this is the expensive Tesla car with specifications. I want to find out the car with the lowest price in the data set. So this is the syntax for lowest price, and I'll equate this with the MSRP. So I'll get the lowest price car. Okay, so many cars, because lowest price is 2000 and almost 748 lowest cars are available in the data set. So how many sedan cars present in the Mercedes-Benz category? So I'll filter out the Mercedes-Benz data first, and Then I will put the count here, and I'll check uh, here. So I have converted this into a data frame. Now this is the sedan is 134, right? But if you want to do it in another way, then what you have to do, you have to put this condition, and you can take the length of this or size of that particular data frame. So it will give you 134 sedan cars are available in the Mercedes category. This is all about the exploratory data analysis of car dataset. This is the complete guide. So thanks for watching. Thank you.